Hi, and welcome to this Microsoft Virtual Academy course on developing Microsoft SQL Server databases. My name's Graeme Malcolm. I'm a senior content developer at Microsoft, and I'm responsible for the data platform content, both in the MVA and the classroom-based training that we deliver through our CPLS channel. Before I joined Microsoft, I was a consultant and a trainer and an author on various data platform technologies, particularly SQL Server. But I'm not the expert in the room today. I'm joined today by Christian Bolton. Christian, can I just ask you to tell us a little bit about yourself?
Thank you, Graeme. You're very kind. My name is Christian Bolton. I work for a company called Coeo. We're based in the UK and we deliver consulting and managed services around the Microsoft data platform. I have a number of certifications, Microsoft Certified Architect Master and an MCT. I also spent 6 years as a SQL Server MVP, and I've written a number of books around internals of SQL Server and troubleshooting.
Fantastic, thank you. So it sounds like we're in good hands. What are we going to do today? Well, we've got a number of topics that we want to get through in this course today. There are 6 modules, each one available as a separate video for you to watch. So I suggest you watch them in order and perhaps take a little bit of time to reflect between each module to make sure you've absorbed everything. We're going to start with a discussion of tables and views and how we might think about implementing those in a database, kind of fundamental building blocks. Then we'll get on to indexes, stored procedures and functions follow that. Then we'll get into transactions and how we manage to maintain atomic data within our database. We'll talk a little bit about the newer in-memory technologies that are available in SQL Server 2014. And then we'll wrap up with a module on optimizing and troubleshooting. So there's a lot of ground to cover today, and hopefully a lot of that will be useful to you. And why will it be useful to you? Well, because what we're trying to do is to, first of all, help people who want to implement databases. So if you're out there and you're perhaps in your job role, you're a developer or you're a database professional and you need to implement a database for an application, hopefully you'll get a lot of good guidance and tips in this class to help you. The other reason that we wanted to create this course is for people who are pursuing certification, and in particular, if you're preparing for the equivalent exam to this course, the Implementing SQL Server Databases exam, then we wanted to provide you with some information to help you do that. Now, I would suggest to you, don't watch this video this morning and then go and do the exam this afternoon, because we're not in the course of, even within the 6 modules we've got, we're not going to be able to cover everything you would need to know to pass the exam. But hopefully we can bring out some of the kind of key points for you to think about and point you off and reference some other material that you can use to help you prepare. And some of that other material to help you as you either prepare for the exam or as you learn to use SQL Server, we've listed on the slide here. There's some suggested supporting material. We have classroom-based training, Microsoft official curriculum, or MOOC as it's called, courses. You can attend a MOOC course at your local CPLS. And we have Microsoft certified trainers throughout the world who are trained and who are experts in delivering content in a more relaxed, longer-term type engagement in a classroom with other students where you can study and learn. So that's a really good option if you learn best in a classroom with an instructor. If you want to learn online, if you want to do this as a more self-paced thing, there are lots of other courses on the MVA. So I suggest you have a look on the Microsoft Virtual Academy site. You can filter by technology. If you filter by SQL Server, you'll see there's a whole bunch of courses there. The other thing I would suggest you do, just flicking onto another slide here, SQL Server, if you've been working with SQL Server for any length of time at all, you probably already know this, but if you haven't, or if you're new to the platform, SQL Server Books Online, or BOL, you'll sometimes see it referred to, is the definitive product documentation for the product. And it's not just documentation in terms of how to use the product. There's guidance and information in there about how to get best use out of it. It's available online on both the TechNet and MSDN websites, and you can download a local version. When you install SQL Server, you can install the documentation locally. I do suggest that you use the online version where possible, because obviously it gets updated and the latest and greatest information will be there. Just to kind of show you what it looks like, I'm just going to flick around. Here's the TechNet version of the site. You can see if you look in the TechNet library and drill down into the product documentation, you'll find books online for SQL Server 2014, and there's the equivalent for other versions as well that you can go to. And if you're not a TechNet aficionado, if you're more on the developer side of things, the same thing is on the MSDN website as well. So you'll find exactly the same structure and the same documentation there. So I do suggest you check that out. Okay, just returning to the slides. If I can get to the right window, there we go. So that's the documentation. I do suggest you use that to supplement whatever training or whatever learning you're doing. There's lots of great information there. And every developer in SQL Server, when they get stuck with the syntax, that's the first place you go. You look in books online. You're on the MVA. That's currently where you are, just in case you weren't paying attention. You're on the MVA website and you're currently viewing this course. The Virtual Academy is more than just a collection of videos. I do suggest you participate in the community, sign up there. You can build up a collection of points and interact with the community there. And learn an awful lot from the various different courses that are in the MVA. So I do suggest keep coming back. There's going to be lots and lots of new courses appearing, and as new versions of technologies come along, we'll be publishing training as quickly as we can. So it's a great place to stay up to date. So that's the introductions. We're ready to jump straight into the first module, and what we're going to do is talk a little bit about implementing tables and views. And I'm going to hand over to Christian because he's the expert. So Christian, take it away and tell us what we're going to be talking about in this module.
Great, thanks Graeme. So I just wanted to reiterate the fact, first of all, that the aim of this course and this module was really to help you prepare towards the Developing Microsoft SQL Server Databases exam. It's not completely self-contained in terms of it providing everything that you would need to take the course, but what we've done in developing the materials and the plan for these modules is really to pick out the areas that we feel as trainers that can be confusing sometimes for people, and also areas of specific interest that may be harder for you to study for on your own, that you may get more kind of support with through demos and discussions throughout the day. So we'll first start talking about tables, schemas and views. Then we're going to have a discussion around temporary tables and table variables. So these are programming constructs, if you like, that are often cause for much debate, and we'll compare and contrast how they're used in that part of the module. And then we're going to talk about common table expressions. Is something that will be is definitely part of the exam syllabus, if you like, and we'll talk about that and some demos of that before talking about table partitioning, which again is another really important part of the syllabus for the exam, and is often misunderstood and overlooked, and be quite difficult if you're studying on your own to grasp some of those concepts.
Sounds good. So there's a lot to cover. Let's dive in and talk a little bit about designing tables.
Sure. So the topic of designing tables itself we could talk about for many, many days. So what I wanted to do first of all is have this kind of introduction and reminder for those of you that have been working with SQL Server for a while. And we'll talk about some discussion points and things that you should bear in mind. And the first one there is really to avoid table names and column names that contain spaces, keywords and symbols. And this is really to help SQL Server and to aid your development, where you can use some of these, but you'll have to put them in square brackets to tell SQL Server not to treat them as keywords. But so as a best practice, it's really good to keep object names simple.
So I should probably avoid things like, I guess, data type names. So don't have a column called date or date time, because that's the name of a data type.
Yeah, exactly. Or a table called table.
Oh, yeah,
Bit confusing as
good
well.
point. I guess if I was running a furniture store, I might have a table called table or something like that. Yeah, okay. So good tip. What else?
So the next one is to plan data types for each column. So your data types really control the type of data that you can have within the column, within your table. But it's not just as simple as saying, I want numbers to go into this column. So if you were representing a number, you might use the integer data type, but we have a tiny int, we have a big int, we have the integer data type, and they allow for different sizes. So it's important that you plan not just for what you think you need, but your kind of capacity and growth expectations around the data types, and use those appropriately.
And I guess as well, we talked about numerical data types and getting the size of the integer right. I guess with strings or with text data, you want to think about whether it's a fixed length or a variable length and consider that as well.
Yes, yeah, absolutely.
Okay, great.
So the next one is planning to whether to allow nulls. So a null is the absence of any data rather than being zero. And what's interesting about nulls, or what you need to bear in mind, is that you can't do calculations on nulls. So we kind of have to handle them a little bit differently within the code. So it's a good idea to try and avoid nulls, but there are a lot of situations, and there'll be debates around designing tables and schemas. So, for example, it'd be quite easy to not allow null on somebody's age, for example, because everybody has an age. But if you were storing a record of a person and you didn't know what their date of birth was, it may be more appropriate to have a null value, an absence of a value, than make up something like, I don't know, 1st of January 1900 or something, the absence of data. So it's important that you plan for your use of nulls and try and avoid them if it's appropriate, because it will make your life easier.
Sure, and the thing I quite often point out about nulls is, to a certain extent, null means we don't know what the value here is.
Yeah.
And one of the things you'll find as you're developing a database, if you have got nulls in the database, it makes checking for equality very difficult. Find people who have the same last name. Well, is that unknown last name the same as that unknown last name? Well, we don't know, because we don't know what the last names are. So you have to be pretty careful about deciding when it's appropriate to use nulls.
Yeah, exactly. And that's the important thing. It's not sufficient to say, I'm not going to allow nulls on everything generally, because there are situations where it's better to have a null rather than to make up a value.
Okay.
So the next one is really around planning your primary key and foreign key constraints. And again, this is an area that we could talk about for several hours, but primary keys and foreign keys are how SQL Server helps you to maintain the referential integrity of your data. And by that, I mean, we'll have a look in a demo shortly, but we're talking about grouping together related data like customers and orders and order details. We'll have a look at more detail in the demo coming up around that.
Fantastic.
And the final one is really around planning indexes to optimize performance. So again, indexing is coming up in the next module. We'll talk about in a bit more depth, but it's definitely a really important area when you're thinking about designing your tables, is how you're going to be accessing those tables and what appropriate indexes would be to improve the performance on those tables.
Great. And as you say, there's a whole module on indexing coming up. Yeah. But when you're creating a table at that point, you may initially think about, well, I want to have an index on, say, the primary key column or a column that's frequently searched. Or
exactly, whatever. Yeah. So it's important to bear it in mind right at the beginning.
Great. Okay, brilliant. Well, with that, you'll see quite a few of these slides today. We're going to try and show you as much of this stuff as we can. So it's a demo that we're going to jump to. And with that, we'll switch across to Christian's machine, and he can show you how this works.
Great. Thanks, Graeme. So in this demo, first of all, we're going to create a new database called DemoDB, just to provide a new context for the setup. Then we're going to use DemoDB. So the first statement we're going to look at is this create table. So we're going to create a table called customer. So this is within a schema called DBO, and we're going to talk about schemas in the next section. And within this customer table, we've first of all got a column called customer ID, which we can see has a data type of integer, which we use int for short, but it's also been set as an identity column. So this means that we're not going to have to supply a value for this. SQL Server is automatically going to generate a value as we insert this, and we'll use this for identifying the rows.
And the identity, I see you've got 1 there, so it's going to start at 1 and go up in ones.
Yeah, okay. Exactly. And we'll also specify this as a primary key, and then we're going to create another table to reference that primary key.
Okay.
So the other column we have here is customer name, and that has a data type of nvarchar or nvarchar, and this basically means we have a variable length character field of up to 50 characters. Now the n means that we can store Unicode data, so characters from other languages, basically special characters.
So kanji characters or whatever.
Yeah, exactly.
And there's a varchar equivalent, which is just your straightforward ASCII values. Yeah.
So the way to think about nvarchar is that it's twice as much to store Unicode data, so nvarchar, as it is to store varchar. But if you're looking at international data sets, or you don't know if you're going to involve international data sets, particularly with names and different characters within names, it's better to err on the side of using Unicode data types. We're also specifying customer name as not null. Remember we just talked about not null, because there's no point having a record that for a customer that doesn't have a customer name. So let's go ahead and create that table. And
just while you're creating that, just to kind of point out, this is a fairly simple demo. We've got customer name there, so we've obviously got the entire customer name first and last in the one column. In reality, that's not how we would design a database.
Yes, yeah, correct. It's fine for the purposes of a demo, obviously, but there's a whole domain around this called normalization, and if we were to design this table to third normal form, we would separate out customer name because it's multiple values within a single column, and we don't want to do that if we're designing to third normal form. So I would definitely encourage you to go and have a look at the topic of normalization, and particularly with third normal form, which is what we tend to design tables to.
So if you're preparing for the exam, then clearly a little bit about understanding how you would normalize the schema of a database to separate out your data into multiple tables and columns.
Exactly. And you can imagine a very fair exam question asking you to normalize a schema design, so you need to be familiar with what that means.
Okay, fantastic.
So this next statement here, we're going to insert some values into the customer table. So this insert statement, you notice that I'm specifying two values in here, two customer names. I'm not having to specify a customer ID because it's an identity column. You remember I mentioned that SQL Server will automatically generate those values for us.
So I guess what's interesting about the insert statement is, a lot of the time you're used to seeing an insert statement that just inserts one row.
Yeah.
In this case, we're using one insert statement to insert two rows. Each of those rows in the table will actually have two values, but because one of them is an identity, we don't have to explicitly specify.
Yeah.
Right.
So then the next table we're creating here is a customer order table. So let's have a look at that. So we're creating another ID column. And for this is also an identity column, and we're starting that from 1,000,001, and we'll increase that by 1. This is also the primary key.
Okay.
We're also creating a customer ID column. You remember we have a customer ID in the customer table as well up here.
Yep.
And what we're saying is that this customer ID column is a foreign key that references the customer table we've just created based on customer ID. So we're creating a relationship between this value in this table and customer ID in the customer table.
And I guess it's worth pointing out that's a kind of key, if you pardon the pun, it's a core part of database design. The reason it's a relational database is because we have multiple tables, which sometimes we call relations, and there are relationships between them. Yeah.
Yeah. So, and this is where we use primary keys and foreign keys to help to ask SQL Server effectively to help us maintain referential integrity. So this is the term when we talk about primary keys and foreign keys, is referential integrity. If you want to kind of follow that up and really understand what we mean by that. And you could maintain referential integrity yourself in the application layer. You could enforce the data structures there, but it's much easier generally to get SQL Server to handle that for you.
Okay.
And we're also creating another column here called order amount, which has a decimal data type, which is going to allow for 18 numbers and then 2 numbers after a decimal point.
Oh, so you're expecting fairly big orders then?
Hopefully.
Oh, okay.
I'm betting on the future. Okay, so that was created successfully. So now if we have a look at our customer table, so we have those two names that we created, automatically generated customer IDs. Mm-hmm. Now I'm going to create, insert some values into my customer orders table.
Okay.
So if we look back at the structure of that table, remember we've got customer order ID, so we're not specifying a value for that because it's an identity column. Okay. Then we've got to specify a customer ID, so this is the first value here, and then the order amount. Okay. So I'm creating two orders, one for customer 1 and one for customer 2.
And if I wanted to insert an order ID, if I had a specific order ID I wanted to insert, can I override the identity? Is there a way of doing that?
I don't know, actually. Can you enforce that?
You can set identity off.
Yes, yeah. Yes, correct. Yeah. I mean, so that's a way for controlling if you're removing data and adding data later on, you could override that insert. Right. But you need to be very careful about what's being created.
Absolutely, yeah.
So where did we get to? Did we insert these? Oh, I've inserted
we've doubled up because I distracted you, but that's
there
okay.
You go. No, that's fine. So we've got some extra orders here. So now I'm going to insert another row in here. I'm going to try to, but you notice this is customer ID of 3, which we haven't created.
Okay.
So this is giving us this error message because we're in violation of the foreign key constraint. So what we've specified is because we have a foreign key back to the primary key on the customer table, I can't have orders that aren't referenced to a customer, which is valid in this kind of business scenario.
So, and you didn't explicitly create a foreign key with that name, it's generated that.
Yes, it's
kind
exactly,
of weird name there.
It's automatically generated that name there. Okay. So the next part of the demo, so we're going to try and delete a customer. So we've got customer ID 1, which we know we've created. They've asked to be removed from our mailing list. They're not interested in having, being a customer anymore. Okay. Sorry, scroll down there. But what it's telling me is that, again, I'm in violation of this foreign key constraint. That's because the customer that we're trying to remove still has orders in the orders table. So, and if we were able to remove this customer, we'd have some orphaned orders that we couldn't track back to work out who ordered them.
And just to be clear, it's not just because there is a foreign key constraint. If the customer didn't have any orders, then there wouldn't be a problem. We could delete them.
Correct, yeah. Okay. It's because there's a relationship with data in the other table.
I see.
So what we're going to do in this next part, we're going to alter table. We're going to alter table customer order. We're going to drop the constraint. So the foreign key that we created when we defined the table, we refer to as a constraint because it constrains the data that can go into that column. I took a copy of that foreign key name that was automatically generated.
And this is the issue when it automatically generates the name. You don't know ahead of time. Yeah,
exactly. So we'll drop that constraint. And then we're going to alter the customer order table again. We're going to add the constraint so we can control the naming of that foreign key this time. So we're specifying exactly the same things, that it's a foreign key on customer ID, which references the customer table, customer ID column. But this time we're going to add an on-delete cascade.
Okay.
So I'll explain what that means in a minute. So now we've re-added that foreign key constraint. Look at the customer orders table. So the customer orders table, we have customer ID 1 has two orders within this table. And if we try and delete that customer now, so we noticed it failed before, but because we've created the foreign key constraint with an on-delete cascade, what it means is we've removed the customer, but we've also removed the orders that were associated to that customer.
Okay.
So this is quite a powerful option, and with great power comes great responsibility. in the fact that if you make a mistake on that, then it's going to cascade your deletes through the rest of your data. And in generally, when we're working with applications and environments, it's an unusual event to remove data. So we would generally not use on-delete cascade because we're trying to mitigate any risk, basically. But it's a very useful feature as long as you've got the confidence that you can control its use, basically.
I guess it's worth pointing out that there's an equivalent for update. We can do updates cascade. So in a slightly bizarre scenario, if I changed a customer's ID, I could then change the matching ID in the orders table as well, which is even less common a scenario, I guess, than deleting.
But I mean, it's definitely important. And again, when we're looking at features like this and the way that you can use the language and the constructs, you need to be aware of what's possible more than, we're not saying this is how you should do it, but certainly for everyday use and for the purposes of the exam, you need to be aware of these features and how you could design it for very specific scenarios.
Great, okay. Well, just before we move away from the demo, I did want to drill into one more thing, just in a little bit more depth. Could you possibly scroll back up to the create table statement?
Sure.
Fundamentally, this module is about creating tables, so let's talk a little bit more about that. And there it is, okay.
Can we go for this one?
Yep, that's fine. So we have this create table statement. The syntax is create table, the name of the table, including the schema. And that's we'll talk about schemas later on, but it's worth getting into the habit, I guess, to explicitly specify the schema and the table name. And then for each of the different columns that we're defining in that table, we've got a name, a data type, and then if there's additional attributes of that column that we want to include, like this one's an identity column and it's the primary key, so we specify them. What we haven't done here is explicitly said, well, where physically on the disk should the data in this table be stored? And that might be something I'd want to do. I might have a table that's accessed frequently and I want to make sure it's stored on a solid state drive, and a table that's perhaps archived data that I'm quite happy to store on a mechanical drive.
Yeah.
Can you talk to me a little bit about how I manage that storage?
Sure. So the feature within SQL Server to manage that is called file groups.
Okay.
So if we have a look in, do we still have this?
DemoDB, you probably have to refresh your list of databases, I think, in Object Explorer. There you go.
So if we have a look at the properties of DemoDB, what we'll see here is that we've got one of these tabs called File Groups. So we have one file group called Primary, so you'll always have this when you create a database. And this basically contains the MDF, so the master data file that you would have for any database. And if you wanted to create additional file groups, we could create one called... so should we call that fast disk? And then if we switch over to files, and we wanted to add another file, let's call that, we'll call that fast disk file. And then I'm going to specify, I'm going to put this in the fast disk file group.
Okay.
And then I don't actually have any other drives on here, but essentially what I would do is to specify
where that
I'm going to put it on a fast drive and an SSD disk. And then when I'm creating the table, I would create it on the fast disk file group.
And that's literally the syntax at the end of the create table statement is on and the name of the file.
Yeah, exactly.
So, and I guess again, if you are preparing for the exam, one thing to think about here, we're not going to dive into file groups in any more depth in this course. I do suggest you go and look at the documentation, and one of the things you would probably want to do in a database is use that primary file group that's there by default for the system tables that the database uses to maintain its own metadata, but then explicitly create file groups for the data that you want to create, where you want to create your tables, and make one of those the default, so that even if you don't specify on which file group, that's where it would go. So do go and look up file groups in the documentation. There's a lot of good stuff in there.
Absolutely. It's a good best practice to not use the primary file group.
Yeah.
When we look at recovery options, I think is in the next course that we do, because you can do recovery of specific files and file groups, and if you've grouped everything into different file groups, it can allow you a bit more flexibility in how to do that.
Okay, great. So let's draw our attention to schemas. We saw some in the example there, or at least we saw the DBO schema.
Yeah.
Tell us a little bit more about schemas.
So the idea behind schemas, first of all, where we use schemas is for a naming boundary. So it's a way for us to logically group database objects, and this is where we talked about using the schema name when referencing objects before, and this is really important when we talk about name resolution of objects.
So in theory, I mean, we've got the fully qualified name, if you like, down there is actually the SQL Server instance that the thing is on,
Sure,
the
yeah.
database. Usually you skip that because normally you're working within a specific database. That's the context that you're working within. But then within that, I've got schemas and objects. So I could, in theory, have a sales schema that has products in it, and I could have a production schema that also has products in it. So it's the fully qualified name.
Yeah.
Both parts makes it unique.
Exactly. And, interesting areas. So this is what we call a 4-part name that we've got on the slide there. And as you mentioned, Graeme, so we would normally reference a schema in the object because we're in the context of a database, in the context of a server. So you could specify the whole thing, but generally we would use a schema and object name. And interesting areas where we've used this in the past, or I've seen it used, is a development schema and a production schema is a way of having kind of naming boundaries. And if you see anything in a development schema on a production server, you know something's gone wrong in moving the code from development into production environments.
Good enough.
So it's a way of providing a naming boundary of there may be grouping around business functions or the way that you use the database or the application itself.
Okay, great. So.
And the next part is really around a security boundary, so we can apply specific security to schemas. So if you wanted to provide access for a new user to everything within a specific schema, or a set of tables and objects, you would put them within a schema, and it makes it easier to be more specific about the security and an access that we want to provide to users. And here's an example at the bottom of the slide where we can use grant execute command to allow somebody to execute any code that's part of the sales schema.
So I guess in this example, if I had multiple store procedures in there, rather than explicitly granting execute on each individual store procedure, granting it on the schema, it then inherits that permission.
Yes,
again. Yeah.
exactly.
Okay.
Exactly.
All right, so tell me a little bit about, we talked about the naming boundaries. Tell me about how SQL Server goes about resolving cases where I don't specify the schema.
Yeah, so this is a really important point. A performance tuning tip is around this default schema and naming resolution. So if I did a select star from table, for example, and I didn't specify the schema, what SQL Server will do is first of all have a look at your default schema, if you've got a default schema defined. And if that object doesn't exist within your default schema, then we'll try the DBO schema. And if it doesn't exist within the DBO schema, then we'll return an object not found. So that's fine and that's straightforward and easy to follow, but where we've seen this cause a problem, and again, and this leads on to this tip around always use this 2-part naming convention of schema and object name, is really in scalability. If you have a user in the sales schema and it is referencing an object in the DBO schema, it will work. and you won't notice any different, and it's very, very fast. But you scale that up to thousands of users and thousands of transactions, all of a sudden this extra check of is it in the default schema, no, let me check the DBO schema, can cause significant scalability issues. So it's best, no matter how small, to start with this two-part naming convention, because as you scale, you'll be very pleased that you started off as a best practice.
I guess it's like anything else. I always say to people who are developing anything in SQL Server, yes, there's default behavior for everything, but it's best to be explicit. So when you're creating a table, depending on the way that you've configured the database, it will either allow nulls or it won't, and you don't have to specify, but it's best to be explicit. It's best to be clear about what you want. And the same is true when you're dealing with objects. It's best to be clear it's that object in that schema that I want to access. Okay, great.
Yeah, exactly. It's one of the benefits and detriments to SQL Server in a lot of things just work. But what you need to appreciate is what goes in the background to make it look like it works. So if you can be very specific about what you're asking it to do, you're not relying on SQL Server or giving it extra work to do to try and to make it work for you.
Okay, great, thanks. So hey, I told you we'd see a lot of these slides. We've got another demo, and you're going to show us exactly how schemas work. So let's switch to the demo machine.
So within DemoDB, I'm going to create, so we have this create schema statement here. I'm going to create a new schema called reporting, and authorization effectively is going to I'm telling SQL Server that I want the DBO, so the database owner user within the database, to own the reporting schema.
And I guess it's just worth pointing out, obviously you and I have worked with SQL Server for more years than I care to remember, but for those of you who haven't, this can be a little point of confusion, so let me just pull this out. There is a schema called DBO in every database, and there is also a user called DBO in every database.
That's a good point.
Historically, that's because I think prior to version SQL Server 2005, objects were named after whoever owned them, whichever user owned the object. So there was always a DBO, which stands for database owner, and the DBO would own objects that were created by an administrator. To bring this in line with more kind of standards across multiple database systems, the ideas of schemas were introduced in SQL Server 2005, but obviously to maintain compatibility with code from earlier versions of SQL, we still had this notion of a user called DBO, so we created a schema called DBO so that code would continue to work. So the potential point of confusion, and I hope I haven't confused you even more, but there is always a user called DBO, which is think of it as being about the administrative user for that database. It's the database owner. But there's also a matching schema called DBO, and it's useful not to get the two of them mixed up.
It's a very good point, actually, and yeah, I can appreciate how I could have made assumptions there, because like you said, in older versions of SQL Server, before we had schemas, we still had this two-part naming conventions, but it was actually the owner of the object. And then the concept of schemas came in, which was much broader than the owner. It was more kind of grouping of objects. But to maintain backwards compatibility, we still have these constructs of DBO and these uses.
Sure.
So what I'm saying here is I'm creating a schema called reporting, which is owned by the DBO user within the DemoDB database.
Great.
So I'm also going to create a schema called operations, owned by DBO. But because I'm executing this as a single statement, the flights table should hopefully be within the operations schema.
Okay.
Good. Well, that worked. And we'll go and have a look at that now. So we can see we have operations flights here, which is what we expected. So we have the flights table created in the operations schema. And we should also have...
Under security.
Oh, there we go, thank you. The schemas, so we have the operations schema and the reporting schema that we created as a separate event. So let's drop that table. and drop the operations schema.
Okay.
So now I'm going to execute these separately. So I'm going to create a schema called operations,
Okay.
which if we refresh that, I still have...
It's still there, yeah.
Yeah, operations schema. Then I'm going to create a table called flights.
Okay.
So if we have a look for this table again now, you notice it's been created in the DBO schema, and that's because my default schema is DBO, and that's exactly where it's gone because I didn't specify the schema to create it in.
Or indeed, if you didn't have a default schema, it would
Exactly,
default to DBO,
yeah.
the default, if you like.
Yeah, exactly. And the other interesting point that I wanted to put at the end here is this exact same table I'm going to create again in the reporting schema, and this is where you need to be careful, and it helps for you to be specific about the schema you're referring to. I have two tables in this database called flights, one in the DBO schema and one in the reporting schema.
So back to the example on the slide, if I did a select star from, well, I wouldn't do select star, I'd do select the columns I want because that's the best practice. From flights, the specific flights table it would query is going to depend on whether or not my default schema is reporting or DBO, or I don't have a default schema.
Exactly. So you could end up getting having to troubleshoot a problem where you're not seeing the data you expect, and that's because you weren't specific about the schema that you wanted to reference.
Fantastic, thanks. And we'll move on from that demo and talk about views. So we've talked about tables, and I kind of get tables are where the data is stored. Tell me a little bit about views.
So a view you can think about as a virtual table within the database. So it's an object that's referenced in the same way as a table. So you would select column names from a view name,
Okay.
and there's nothing from that query. You wouldn't know whether that was a table or a view. And then when we're creating the view itself, is basically you're creating a view based on a select query. So if we have a look at the code on the screen now, so we have this create view statement. We're following best practice. We've got human resources schema here, and we're creating a view called employee list based on that select statement.
Okay, so and I'm guessing, I mean, with the select statement here, it's fairly simple. We're selecting some columns from one underlying table. I'm guessing I could have views that are based on multiple underlying tables.
Exactly. And this is that can be quite powerful with views in the fact that select statement could have a join to bring a single result set, and then you would use that as if it was a single table.
Okay, great, thanks.
So moving on to more detail around the views. So a view doesn't persist data unless you have an indexed view. So an indexed view, we'll come on to that point actually. So if you think about normal views, it doesn't persist the data. So the data doesn't exist. And when you reference that view, it will pull the data from the underlying tables.
So that the query in the view definition is executed when I query the view?
Exactly, right, in order to turn the data to you. So another point to mention around here as well is this with schema binding option. So if you think about the scenario where you create a view that's used by your application, selects a number of columns, and you're presenting that through your application, if somebody removes a column from the underlying table that your view is dependent on, that view is then broken. Okay. So what we would do is to create a view with schema binding to prevent schema changes to the underlying table from breaking the views that we're using.
So it prevents changes to the definition of the underlying table. I can still add and delete data directly at the table.
Absolutely.
Yeah,
absolutely.
Sure. Okay.
So it means that the columns that I have in the view can't be removed from the underlying table because it would break the views. So it's very common to use schema binding for important views.
Okay.
So the next point that I wanted to make here was if you add a unique clustered index, and we're going to talk about indexes in the next module, if you add a unique clustered index to a view, it will make it an indexed view. And what's interesting for that is that it then persists the data independently.
Okay, so independently of the table.
Of the table and the view. So the view is a virtual table, and we mentioned before that when you select data from that view, it selects it from the underlying table. But if we put a clustered index on that view, it's actually going to generate a new physical table, effectively, called an indexed view.
Right, okay. Oh, so there's a point there to talk about that.
Yeah,
okay.
that's fine. So it's persisted to disk in its own right to improve performance. Because if you've got to do calculations within that view, you can pre-calculate them and have them persisted on disk.
Oh, so I could, for example, have an orders table that has, I don't know, the price and the tax, and then calculate the total price.
Yeah, exactly.
Right, okay.
So an indexed view, it's again, great power comes great responsibility, not to overdo indexed views. And there could be an argument for saying, if I need an indexed view, should I really does it mean that I haven't designed my schema properly?
Sure.
If I'm having to create these new constructs? But something that's very important for you to remember in general, and certainly for the exam, is around this concept of an indexed view. And Enterprise Edition has a feature where the optimizer within Enterprise Edition will automatically use indexed views to improve the performance of other queries. So it will treat it exactly what it is as an index, and it will use an indexed view to improve the performance of other features.
Oh, okay.
But you will only get that with Enterprise Edition features.
Right.
With this Enterprise Edition feature. So you can imagine, an exam scenario, an exam question where you have Standard Edition, you can see where it's leading you with this indexed view, but you don't have Enterprise Edition, so SQL Server won't automatically use this indexed view to improve the performance of the other queries.
Okay, just to be clear, I can create index views in Standard Edition.
Yes.
It's just the optimizer doesn't.
Exactly. So you can create the index views, and the application that you're creating the indexed view for, you would use that very successfully. But the Enterprise Edition will then use that in other areas of the application in SQL Server.
Okay, good enough.
So, and the final point there is the inserts and updates. So we can use views to do inserts and updates to the underlying tables,
okay.
But not if it was based on multiple tables.
Well, I guess more specifically, if it's based on multiple underlying tables, I can do an update to the view which affects only one of those tables.
Yes, sorry,
yeah.
yes, correct, yeah.
But I can't. So if I had a view that showed me customers and orders combined, I couldn't do an update that changed a customer's name and changed an order at the same time.
Yeah, correct.
Okay. Well, you're up again. It's time for another demo. You're going to show us a little bit about views. So let's switch across.
So in this demo, we're going to use the AdventureWorks database, which is the kind of default sample database that you'll see if you've been doing lots of different training courses. And I'm going to create a new view in the person schema, which is called individuals with email, which is going to be based on this select statement.
So this one is based on two underlying tables then?
Yes, yeah. So I can execute that select statement. And basically what I'm saying when I'm creating this view is this kind of predefined select statement. So I create this view of individuals with emails, and when I query that view, that's the equivalent of me executing this select statement here.
Okay, so from the point of view of creating, I guess, an abstraction layer for an application, the application developer can write much simpler queries because the views encapsulate the more complex transaction. Okay.
So, so what this then enables us to do, like you said, the simplification of it. I could do a select star from, naughty me, I should have done the all the columns as best practice.
We'll forgive you in the
So a select star from individuals with the email, but then I can order it by last name, so I can reorder the results, I can aggregate the results, I can do anything that I want with it effectively.
So it is, I mean, it's very exactly the same as querying a table.
Yes, yeah, exactly. It just makes things a bit simpler, basically. So I can also have a look at the definition of this view here. So by using this statement here, what I'm saying is, show me the construct of this view, which is giving me this create view statement. And I could get the same thing by going to the AdventureWorks database, person individuals with email, and I could do this script view as create. Is going to give me the definition that I created. And the reason that I wanted to show you this was really to move on to this with encryption option that you have here. So essentially what this will enable you to do is to hide the definition of the view to stop people scripting it out.
So it's quite confusing terminology, because just looking at that, if I didn't know any better, I would assume that meant the data will be encrypted.
Okay,
but of course it doesn't mean that at all.
Yeah, absolutely. So it's the definition of the view that's encrypted here. So if I do that same view definition, you'll find that we actually get a null result here. So, and what you'll find is, this feature will be used for companies that write software for SQL Server that they then sell to customers, and they might not want their complex IP that was written within a view to be scriptable by other people for reuse. So they might use the with encryption keyword.
So they're protecting themselves from intellectual theft, I guess.
Yes, yeah, exactly. And, I don't see it used very often because it can make troubleshooting difficult. Sure. But certainly as a feature and an option within the product, it's something that you need to be aware of. And, if you were troubleshooting and you were trying to script this out and finding that you were getting null results, if you knew that there was this with encryption keyword there, it will help to put the pieces together and not think SQL Server's broken because I can't script out this view.
Okay.
So again, let's drop that. And we've done this one already. So if we have a look at any of these other ones, and this script view as is most often what I would use if I'm kind of troubleshooting and looking at definitions of views and store procedures and anything like that. It's
just this ability to script things using the user interface in SQL Server Management Studio is one of these features that I really love. I remember working with a guy who was an Exchange server administrator, and he would have killed to be able to point at things in the Exchange UI and just script the PowerShell that's required to create them. So yeah, fantastic, great. That was views. Now, views we thought of as being kind of virtual tables. Now we're going to talk about something slightly different. We're going to talk about temporary tables.
Temporary tables. So temporary tables is a very common and useful topic within SQL Server. And remember, this section we're going to compare and contrast temporary tables and table variables. Okay. So let's look at temporary tables first. So temporary tables are used to hold temporary result sets within a user's session. So effectively, if you wanted to create a loading table, you would put that within tempdb, because tempdb we would use like a scratch database. When SQL Server restarts, tempdb is effectively recreated. So all of these temporary tables would be gone. They're not kind of persisted beyond reboots.
Just very much a sort of workspace.
Yeah,
table, right?
exactly,
okay.
exactly. So they're created in tempdb, they're deleted automatically. So if you create it, like we have in the example here, we have a hash or is it a pound in the US?
Our American cousins would call it a pound symbol. I would call it although hashtag has become the thing, so it's a little confusing.
So TMP products. So create table hash TMP products would create a locally scoped temporary table. And if we used two hashes, that would be a global temporary table.
And so the difference, the difference being?
So with a single hash that we have in the bullet on there, it's scoped to the session that you're in. So that table will exist while you're executing in the session that
connection that you've opened.
Yeah, that connects to SQL Server, but only you will be able to access it. But the next bullet here, which has the double hash prefix, will create a global temporary table. So any session will be able to reference that global temporary table. It's not something that has much of a use case scenario these days. So mostly we would use locally scoped temporary tables, because if you had a table that you wanted multiple user sessions to be able to access, then you generally create a normal table anyway.
Okay.
It can be quite difficult to troubleshoot and provide, access to global temporary tables.
Okay, great. So that's temporary tables. You said we were going to compare them to table variables, so let's look at those.
Sure. So table variables were introduced around SQL 7, SQL 2000, something around that kind of time frame. And they were introduced because of the nature of temporary tables. They're basically like normal tables in a normal database. And SQL Server maintains what's called a set of statistics, and again we'll talk about that in the next module. So statistics contain data about the distribution of data within the table, and as the data within the table changes, the distribution data changes, statistics will get automatically updated, and when statistics are updated, it can generate a recompilation of the code that you were using, which can then give you a different execution plan. So it can cause performance problems generally.
You're creating a lot of additional work unnecessarily because the tables are temporary anyway.
Exactly.
Okay.
So then this the concept of a table variable was brought in, which is used similarly to temporary tables, but it's scoped to a batch. So it's scoped to a piece of code that you're running rather than the whole session. Okay. It will make more sense when we have a look at the demo. All right. But the key thing to realize with table variables is that there are no statistics on table variables. So the fact that there are no statistics means that changes don't cause recompilations of the code using those table variables, which can be a good thing if recompilations is a problem. But because on the next bullet, the estimates are always one row, it can be very effective for small data sets. Because if you've got 10 rows and the optimizer estimates one row coming out of that table, then that's fine. But if you've got 100,000 rows and the optimizer expects one row, that can change the way that SQL Server optimizes the code that you're running.
And I'm going to guess, to use that example, it's an extreme example, but if you're designing a database and you've got a variable that's going to hold 10,000 rows, then I think there's probably more fundamental problems with your database design, I think.
Yes, but I mean, we see a lot of customers that we deal with when we're troubleshooting and looking at health check scenarios and the way things have been developed, where things start off small and you start off with 10 rows, and if you've got 10 rows, table variable is actually quite a useful construct of storing temporary data. But 2 years later, that 10 rows has expanded, it's now 100,000 rows. We've seen scenarios where table variables are great to use and developers just use them everywhere because they seem like they're better than temporary tables. But it's just that they're kind of different, and you need to understand the pros and cons of them both. But in general, table variables only use on very small data sets, and that's because SQL Server doesn't maintain statistics on table variables.
So, once again, over to your demo machine, and let's take a look at these two things.
So for this example, I'm going to use a database called People. I'm going to create a temporary table called People, which has all of these columns in. So personal ID, first name, last name, date of birth, date of death, and sex. I'm going to populate the table by inserting into hash people, by selecting the top 250 rows, all of the columns, from a normal table called People.
Okay.
appreciate that the naming may be a little bit confusing here.
Okay.
But
just remember the
basically,
hash one is the temporary one.
yes, correct, yeah. So if I have a look at account star from hash people, I have 250 rows.
Okay.
So what I'm doing here is counting all of the rows within that table.
Okay.
I have 250 rows in hash people. Now if I disconnect this session, reconnect.
And just to be clear, that even though it's the same window, this is now a different session
Yes,
because we've closed and
correct,
reopened
yeah.
the connection.
So this table name is invalid because we've disconnected and we've come back with a new session, and because it's scoped to a session, it only existed in the previous session. So I'm going to do the same thing with the table variable.